My name is Ryan Stahersky. I am the treasurer of the Hackerspace Charlotte.
Hello, this is Quincy Acklin with Hackerspace Charlotte.
What's your name?
Paul.
Why?
My name is Enrique.
My name is Amelia Masholi.
Check out our fabulous felt.
And what menagerie of felt is this?
I actually don't know.
And what is the purpose of our project?
Oh, no.
Education.
Yes. Yes.
Building, teaching electronic circuitry to kids and making it more accessible.
What we have is an FM transmitter. The output of this antenna on your radio, somewhere around 90.0. It's where you want to tune your radio to.
That's a radio?
I don't know
Transmitter?
what the hell this is.
I am working on a project for Hackerspace Charlotte for Element 14's Great Global Hackerspace Challenge. And I am building, our project's called Fuzzy Logic, and I am building big fuzzy components so we can teach children how to use electronic circuits. I am making big fuzzy logic components. I'm wrapping this magnet.
What's your favorite component?
Transistor? Is that what this is?
All right.
That's my favorite one.
All right.
I'm working over here as a cutter.
Okay, you can imagine two small
I
countries.
cut with my scissors,
Over the rising comments.
and we
Quarter-mile
design all these
geodesic
little
spheres.
things. Then I give it to him. And I don't know what he does with it.
Now, how much background do you have in electronics?
0.
0. But you can do this, right?
Yes.
So what we're doing now is we are cutting out some templates so we can make these components fast. So we're just going to cut them out of some acrylic here with this CNC machine that Quincy built, and here we go. All right, and you're left with this.
We just get this near and that magnet clicks, and then we get this near and that magnet clicks, and lo and behold, our LED is on. If we break the circuit, our LED turns off. So here we go, we connect the circuit and the LED turns on. So kind of a nifty quick little test. One of the things that we're doing is creating some new transistors. For our new transistors, we've soldered on some connectors to make things a little bit easier for us, since we figure that a transistor is a slightly more disposable component. We decided to put some of these little sockets right here on the transistor, so you can just pop them in and out. Of course, we wanted to wire all the runs together that needed to be, so emitters, the emitter on both sides, and it doesn't matter which side you plug it in, since a transistor only has 3 prongs, and here you can see we've got six different places to plug that transistor in. Anyway, that's our new transistor, and hopefully that will make life here a lot easier. This is our voltmeter. It's not a multimeter. It only does one thing. This is a Diavolino, so a Arduino knockoff that is basically the same thing. And for our purposes, it certainly works. We've got a power supply over here to power our little bad boy. Some may say this is even portable. Anyhow, this is our test probe. Everything's grounded here, but we can actually plug in a different probe into our ground lead there to ground out the circuit and make a test. For us, we have a 5-volt contact conveniently located right here. And when we touch that, you'll see that throws our servo, calibrated distance, and it's hot. So what you end up with is hopefully 5 volts, and we get 5 volts. So this is how we will measure our fuzzy logic circuits on the board over there, is with this handy-dandy little felt and microcontroller controlled meter. This allows us to show kids in the back of the classroom, what voltage is present in the circuit. If you're in the back of the classroom, can you tell that there's voltage there? Absolutely. And that's what we're after. A little multimeter is not going to do that. So we wanted something that's scaled up with the rest of our radio circuit. So again, this is something that's easy, the kids can see it, and then you can take this circuit and you can do so much more with it. To simply plug in a wire here to stick a washer or a magnet on it, and now you've added your Arduino, your ATmega microcontroller into the middle of your Feltlogic circuits. And this represents a simple AND gate. You've got a switch here that if you push it, nothing happens. It doesn't complete the circuit. We have two switches, and if one or the other one is set, nothing happens. But if both are pushed at the same time, if this one and this one, you get the tone and the LED. It requires both of them to be pushed. We can quickly and easily rearrange this to show what an OR gate looks like. So now, all I need is one of them, because it's this switch or this switch. This is Quincy Acklin with Hackerspace Charlotte for the Element 14 Great Global Hackerspace Challenge. As part of our challenge, one of the things that we wanted to do was be able to build an FM radio, a transmitter, out of our Feltronics components. We have a whole variety of felt components. This is what you can do. You can take a circuit and put it together with magnets and see how it works, and that's kind of the power of Feltronics. So this is something that the kids, when they're sitting in the classroom and they see this thing for the first time, and you say, okay, the teacher can do this in advance, and they can say, okay, now we're going to hit this button, and we're going to talk, and you're going to hear it on the radio. So the setup is you kind of have the radio in the background, on the desk, whatever over there. You move over to the board, you have somebody plug in, instead of a microphone, you can just plug into your MP3 player, hit the button to turn it on, and suddenly the radio that you previously tuned, because it takes some work to get it tuned, starts playing what's coming out of your MP3 player across the room from Felt. That's something that's going to pull the kids in and make them go, what? How? And none of these components here are too complicated. There are no black boxes here. The closest thing you get is a transistor, which is something that's not too difficult for kids to understand. And then, you've got a couple of capacitors, some biasing, an antenna, resistors. I mean, it's pretty simple. This is as simple as you can get as far as radios go. And once you've pulled them in and you make them want to learn and you make it fun to learn, the sky's the limit. And that's what we're trying to accomplish here. So, once again, this is Hackerspace Charlotte's entry. Fuzzy Logic, Feltronics, one of the two. Fuzzy Logic by Feltronics. Yes, this is the winning project. So we'll see you at Maker Faire.